Hello, everybody. It's me again, Rich Andre, and today we're going to be solving and talking about vector equations, parametric equations, and symmetric equations. We say so. In order to solve this, you first have to take note of some general formulas, and here they are. Okay. So, given this problem that I've already solved earlier, credits to the organic chemistry tutor for this problem, by the way. So let's read the following. Find the vector equation, parametric equations, and the symmetric equations for the line that passes through the point parentheses 2, 4, negative 3, parentheses, and parallel to the vector 3I minus 2j plus 5k. So in order to solve this, we have to take note of the numbers that are inside these parentheses right here, as well as these, okay? So we have 2, 4, and negative 3. Now these 2, 4, and negative 3, you can assign variables to them. So whatever comes first, okay, whatever set of numbers comes first in the problem, in this case, it's 2, 4, and 3, 2, 4, and negative 3. You can safely bet that these numbers are the R naught. Okay, what we have here is R naught and X, X naught, Y naught, and Z naught. Okay, so we have 2, 4, and negative 3. Now, that whole entire set we can derive or we can denote as R naught. Okay, R0, R sub 0, or whatever you'd like to call it. Okay. So we're trying to solve for the R. Okay. We're trying to solve for R. And in order to solve that, we also need this second set of numbers, which is 3I minus 2j plus 5k. And this is going to be G. Okay. So G is equal to some quantity, okay, T, some quantity T times V, okay, times V, which is the vector, okay, some quantity T times V, and the vector, okay, V is this, V is this second set of numbers right here. So we can derive, or we can denote this, the following numbers with A. It is going to be A, B, C. This is going to be X, X naught, X naught, Y naught, and Z naught. All right. So in order to find the vertex, no. In order to find a vector equation, we have to use this sort of generic formula. R equals R naught plus G. Okay, so let's try it. Okay. Let's try it for this equation. So it says here, find the vector let's try it for this problem. Okay, so it says here, find the vector equation, parametric equations, and symmetric equations for a line that passes through the points 2, negative 1, 4, and 5, 2, 7. Okay, so this first one is going to be R naught. So R naught equals 2, negative 1, 4. This is going to be X naught, Y naught, and Z naught. And the second set of numbers is going to be RV, which is 5, 5, 5, 2, and 7. This is going to be A, it's going to be B, and this is going to be C. Okay, so now we have to find the vector equation And in order to find that, we need to use the generic formula, R equals R naught plus G, provided that G equals T times 7. So plugging those in, we can get these. Okay, so R naught, let's rewrite the generic formula. R naught is, I mean, R is equal to R naught plus G. Okay, so we have to plug these in. So R, so you just have to add that. Okay, so R here is following. Okay, but of course, okay. So R, let's go to R. Okay, so okay. So we have here, let's just use these variables. Okay, let's just use x, y, z as the variables. So we have 2x minus 1x minus 1y, minus 1y plus 4z plus g. Okay, so g is going to be t times v. G is equal to t times v. Now let's use x, y, z again for these variables, for variables of these set numbers for v. Okay, so let's say we have 5x plus 2x plus 7x. Oh, no. 5x plus 2y plus 7z. Okay. Now we have to times all of that with t. So you get 5xt plus 2yt plus 7zt. Now we have to plug that in. Now that we've got t times v, we can just safely plug that in. And this is going to be g. So 5xt, let's just move this. So we have 5xt plus 2y plus 2y t plus 7zt. 7zt. Okay. Now we have to assemble them. Okay. So we just have to put the numbers, okay, the numbers that have the same variable next to them, and order them as such. Okay, so we have 2x. We have 5x plus t, 5xt, okay, 5xt, and then negative 1y. Okay, negative 1y. We have plus 2yt, and then plus 4z plus 4zt. Now what we're going to do here, let's just put parentheses in here, just so we don't, we don't get confused. Okay, so let me just fix this, so we don't get confused. Now we have to factor out x. Okay, now we have to factor out x, y, z, so that t is the only variable remaining in these sets of numbers. So if you factor out x, you're going to have 2 plus 5t, then x. Okay, so plus negative 1y, no, negative 1 plus 2 And then you're gonna have t y and plus 4 plus 4 t and z. Okay. So now these numbers, okay, these numbers right here, they're going to be the these are going to be this is going to be the vector equations. Okay, this is the vector equations. Let's just yeah, let's just denote it as VE as vector equations. So now this is going to be the basis for our parametric equations. So we can just denote these. Okay, this one parentheses as x and y and z. Okay, so you have x, y, and z. Now, in order to find the parametric equations for this problem, we have to use this generic sort of formula right here. We can just copy and paste it. Just copy and paste it. So in order to find the parametric equations, you have x equals x naught plus at, and y equals y naught plus bt, and z equals z naught plus ct. So what we're going to do, okay, we have to extract these numbers and denote it as such. So we have x, we have x equals 2 plus 5t, and y equals -1 plus 2t, and g equals 4 plus 4t. Now, and now we just have to substitute, okay? So in order to find the parametric equations, we have to sort of isolate everything. Isolate t. Okay, we have to isolate t because we're going to find the variable t. So in order to find t using these equations, okay, we're just gonna have to use basic algebra. So now you just have to rewrite the generic formulas. We have t equals x minus x naught divided by a, and then the other one, y. Okay, so for y we have y minus y naught divided by b, and then z, okay, is equal to z minus z naught divided by c. Okay, so now we're just going to substitute the numbers here. Okay, we're just going to substitute the following, which is x naught a, y naught b, and then z naught c. So according to these, okay, we know that these are the this is the r naught first set. This is v, which denotes as abc. So if we take in the following, okay, take in the following numbers, we have x minus 2 over, which is 5, that's b, that's a, 5 here, 5, and then let me just check how to yeah, okay. Actually, this is the part where we get the symmetric equations. We already have the parametric equations, which is this. Okay, this is the parametric equations. I'm sorry for not telling. This is the parametric equations, and now we have the symmetric equations. We're trying to solve the symmetric equations. This is the vector equation. the parametric equations. Now this is the symmetric equations. So now we just have to use these formulas in order to find the symmetric equations. So we have right here, we have to equal them, by the way. You have to set them all to equal. So y minus y naught is -1, which is negative times negative, which is going to be +1. So y plus 1 over b. What is b? Okay, so b is 2. B is 2. Okay, see right there. Now that's going to be equal to z and minus z naught, which is 4, and then 7 is c. So we have 4 and 7. And that's going to be the symmetric equations. Okay, let's check the answer sheet to see if we're right. I know the answer sheet is going to show something probably different, but I'm just going to check if they're on the same page, you know. Okay. Okay. What? This is not what we discussed. Why is it like that? Yeah, I'm just going to completely disregard that, but I know the way I solved the vector equation was right. This is how the chemistry tutor solved for the vector equations. ChatGPT probably has another way, another method to solve for the vector equations, but I'm probably right, you know. So this is going to be 2 plus 5 to 3. Parametric equation is wrong too. What? What the? Hold on, let me just check this. Yeah, I did everything I could. I did everything I should have. Okay. So this is not right. Oddly enough. Okay, no, we're not right. Not correct. This is going to be wrong. This whole thing is going to be wrong. I think it was because I was using this as a basis, maybe, but I want to see how ChatGPT had solved it. Oh my God, I was not given pointers on this. Subtract the first point from the second point. I was not given pointers on this. vector equation of a line is R0 or R naught plus TD. R naught plus TD. Okay, I think I understand it now. I'll just do it again. Alright, so we're just going to redo the solutions because I got it wrong. You see? So let's just denote this as R equals X, Y naught, and 0 naught. Oh, no. Z naught. This is A, B, C. Okay, so let's just use this. Let's first have to use the, what we call that? Yeah, there's a vector sign there. So D, and to find the vector equation, we have to subtract the points. So P2 minus P1, and we get 2 minus 1, 2 minus 5. Oh, no. It's P5 minus 2. 5 minus 2 is 3. Five minus 2. Okay. Just the direction vector. I completely negated this part. So we have 5 minus 2 is 3. And we have 2. We have 2 minus positive, negative 1 is positive 3. 7 minus 4 is 3. So this is our direction vector. And vector equation, in order to get a vector equation, we have to use, how do we denote vector equations? Yes, we have to use this. Okay. R equals R naught plus TD. So we just have to get R naught, which is 2 minus 1, which is 2x. 2x minus 1y plus 4z plus t times d. So we have 3t. So we have 3t, and 3t. Okay. So now we have that. Okay. Just have to get the times 3. Okay, so my bad. It's actually the answer itself. That's actually the answer itself. Okay then, buddy. -1 and 4. Uh-huh. 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 T. Yep, yep, yep. That's going to be our vector, vector equation. I really don't get it. Whenever I go to a chemistry tutor, to learn some math, the way he solves it is almost always different from ChatGPT. Because ChatGPT, I don't know what the hell this clanker is doing, but it's always different. The answer is always different. I have no idea why. So this is the vector equation. Uh-huh. And then we get now we're trying to get the parametric equation, which is just this, parametric equation. How the hell did you solve this, buddy? Ah, so it's just that. Okay. So it says it's advertised, it's 3t x equals 3t y equals y equals 1 plus 3t. We have c, which is positive 4 plus 3t. That's the parametric equation. I was trying to get the symmetric equation. Which is, to get the symmetric equation, you just have to use this formula. So we have x minus what is x naught? That's 2 minus 3 over 3 is equal to x minus negative, which is positive 1. Okay, so 3 we have x plus, oh no, my x minus z is 4 3 4 3. So that's the symmetric equations, right? That's how you get it. That's how you get the stuff. Oh my god, I forgot the variable. Never forget the variables. Got y here and z here. That's beautiful. Right. Now that we're correct, let's do the next numbers ourselves. Let's do the next numbers ourselves. First, So let's just denote everything. Find a vector equation. This is R naught, X naught, Y naught, Z naught, A, B, C. Now we have to get the direction vector. So we have D is equal to R naught plus TD. Wait, no. Direction vector is actually, I got it wrong. It's actually P2 minus P1. Okay, so 1 minus 3, 1 minus negative 3, that's going to be minus negative 3 is, that's going to be 4. Okay, so 5 minus 1, that's 4. Negative 2 minus 2. Okay. Negative 2 minus 2. That's going to be negative 4. So we have D direction vector is equal to 4, 4, 4, negative 4. So negative 4. Whoa! So let's just do the following. No. This is the direction vector. So in order to get the vector equations, you have R naught plus TD. Now you have to do this. Okay, so R naught, what is R naught? That is negative 3 negative 3 1 2 plus TD. So T, we have T here, then E, which is 4, 4, and negative 4. I guess that is the vector equation. That is the vector equation here. So you have R equals, yeah, that's the vector equation. Vector equation. Now we're going to find the parametric equations. We're going to find the parametric equations. So we have PE equals X equals negative 3 plus 4t. Y equals positive 1 plus 4t. Then Z is equal to 2 plus, then we have negative 4 here. Negative 4 times t, just negative 4t. And consequentially, it's going to be negative 4t. Or if you prefer, I guess, just do this. Yeah, you can just have 2 negative minus 4t. Now we're trying to find the symmetric equation. I may be wrong on Z, but symmetric equation, okay? So the generic formula, x minus x naught, a, y minus y naught, b, then we have z minus z naught, c, then you're going to equal that, okay? So let's just substitute the numbers. X minus -3 is going to be +3 over b over a, which is 4, is 4 and -4, and then equal those two. We have y minus 1, z minus z naught. Z naught is 2. So that is the symmetric equations, So let's check the answer. Just check the answer on this. Okay. Vector equation. We're right. Parametric equations. -3 plus 40, 1 plus 40, 2 minus 40. Right. And then lastly, symmetric equations. X plus 3, y minus 1, z minus 2. I am right in everything. Correct. Okay, so that's number 2. Now let's do number 3, and once we get to number 5, we're all done. That is going to be finished, but just pause this for a moment. All right, let's get back to solving these equations. I'm going to do this as fast as I can, So the vector, the vector direction vector. So we just have to label, okay, x naught, y naught, z naught, a, b, c. Okay, so not to do that, we just had to get a direction vector p2 minus p1. We have 2 minus 0, that's 2. Okay, -2 minus 2, -2 minus 2, it's -4, and 2. It's going to be our direction vector. And in order to get vector equations, we have to use r equals r naught plus td. We have td over here, so we have x. We have 0 to -1 plus t times 2 -4 and 2. That's going to be our vector equations. In order to get the parametric equations, we have to get to xy. X equals 0, okay, it's 2t. 0 plus 2t. 0 plus 2t. Y equals 2 minus 4t. Z is equal to -1 plus 2t. That's the parametric equations. Now for the symmetric equations, we have x minus a, that's 0 and a, x minus 0, 2, and it's equal to y minus 2 and -2 equals to z minus -1. It's +1 and 3. +1 and 3. So that's going to be our symmetric equations. Let's check if we're correct. Let's check here. Actually, there's going to be I suspected it was going to be 2t. So 2t, 2 minus 4t, right, 1 plus 4t. I actually made a big mistake here. I should make a big mistake here. That's gonna that's gonna be positive. It's gonna be +4. That's just a small algebraic mistake, you know. No biggie. It's not a big deal unless you're very sensitive. Unless you're a sensitive femboy. It's just actually just 4, you know. So it's gonna be 4t as well. Yeah, 4t. That's gonna be 4t plus 4t x minus. So you just have x over 2. You can just completely disregard -0. For me, honestly, it doesn't even matter if you put it or not. It doesn't really make a lot of difference. It's still 0. So y minus 2, -4, -4 here. We're gonna have -4 here, -4, and then we have 4 here. Yeah, that's basically it. So that's all correct. Now we're just going to have number 4 here, and then we're gonna have the last one. That's basically it. So first things first, direction vector, which is equal to p2 minus p1. We have here r0, x0, y0, and z0, and a, b, c. Yeah. So we have 7 minus 4, that's 3. -3 minus 0, which is gonna be 3. -3 minus 0 is -3. And then 5 minus 1 is 4. So oh, why am I doing number 3 again? That was incorrect. That was incorrect. I was doing number 3 again. Sorry, guys. I'm so sorry. So there's yeah. Yeah, huh? Yeah. Huh? Oh. Oh, so this is what we consider A, B, and C, I guess. T, T, T. Yeah, it's T, T, T. So G, B, and 4. Yeah. So on to the last number. To the last number here. So we have here. So we have R naught. It's gonna be Alright, so that's going to be our video for today. Thank you guys for watching. See you guys in another video. Appreciate it.